Hello and welcome to another video on geology. This video will be about metamorphic rocks. To create a metamorphic rock, you firstly need any other kind of rock. You also need to place that rock in a situation where it has extreme heat and extreme pressure. These two conditions can be satisfied by placing the rock at extreme depths, very deep situations. However, it is still conditional because if it is too deep, it still will not form a metamorphic rock. There is an exception. If it's too deep, the pressure and the temperature will be too high so that the rock will become magma and we will no longer have a metamorphic rock. So at extreme pressures and temperatures, but not too much, we form this special kind of rock. This rock, please direct your attention towards this diagram here. There is the green layer, which is the crust, and the orange massive area, which is the magma. The crust, as you see here, is subducted underneath, and at a certain depth, it begins to melt away. The crust becomes magma, as we just said. But just above it, the crust is still crust, but it is under extreme pressure and it's extremely hot. This is the first kind of scenario where metamorphic rocks can form. We call this regional metamorphism. It means that the entire region has been moved to a situation where extreme heat or extreme pressure is achieved. In the same diagram, we have magma penetrating through the crust, trying to come out, and as you know, maybe forming volcanoes or something. But as this magma passes through, it will encounter other rocks in the crust. And when it comes in contact with other kinds of rocks, it will exert extreme heat, and to an extent less extreme pressure, but there will still be some pressure influences on those rocks, but generally extreme heat. And we call that form of metamorphism contact metamorphism, because the magma has come into contact with the surrounding rocks. So there are two kinds of methods of producing metamorphic rocks: regional metamorphism, contact metamorphism. One is moving the rocks to the magma, and the other one is moving the magma to the rocks. Characteristics of metamorphic rocks. Well, since rocks contain minerals, then those minerals have undergone some kind of chemical or physical change. And generally, when you have a high amount of pressure on it, you could also create different kind of crystal structures. You will form these bands, possibly very visible, sometimes it's not visible. We call these bands foliations. And generally, because they have undergone so much extreme pressures and heat, they are extremely hard. So now with our understanding of metamorphic rocks, we can combine this with everything we have learnt about igneous and sedimentary rocks to create the rock cycle. We know igneous rocks are created by cooling down magma. We know that sedimentary rocks are created by cementing sediments. And we know that metamorphic rocks are created by any other form of rock as long as it has pressure and heat. So let's follow this. Magma becomes igneous rocks, can go back to magma. Igneous rocks can undergo extreme heat to become metamorphic rocks, which can also heat up and melt, becoming magma. Igneous rocks can be weathered down, eroded, becoming sediments. Your metamorphic rocks can be eroded and become sediments. And sediments can also be created by sedimentary rocks. Sediments can become sedimentary rocks based on cementing. Sedimentary rocks can also be melted down to magma. Sedimentary rocks can also form metamorphic rocks undergoing extreme heat and pressures. There is one more arrow I'll add, which is metamorphic rocks to itself, because you can have one kind of metamorphic rock changing into another kind of metamorphic rock. That is extremely rare because you have to replace a large section of minerals and completely warp the structure, but it's not impossible. It does happen. So, last week we talked about granite turning into sandstone and other different kinds of sedimentary rocks. Well, what does sandstone turn into? One possible candidate of sandstone is something called quartzite. It looks like this. It's much harder than sandstone. Good. It generally has the clay, silica minerals in here. There are a few other impurities which I'm not very sure of. At any point, this could melt, and then again we can have that magma cooling down, forming granite again. There's no reason why not. It doesn't happen like that. Sandstone, well, that could melt when it goes deep enough through, if this was sent down through regional metamorphism, then it would cool down and form granite again. So this is all a cycle. In fact, quartzite doesn't actually require extreme pressures. You could form it through something called contact metamorphism. It doesn't necessarily require regional metamorphism. Our example of limestone, well, limestone has a lot of calcium carbonate product in here. It definitely requires regional metamorphism to produce something called marble. Marble, extremely dense, extremely hard, much harder than limestone. Very hard, so you can see the limestone falling apart. Cannot be created through contact metamorphism. And again, this could melt down, forming the igneous equivalent, and the minerals can all mix up and form many different miscellaneous types of igneous rocks. So it always is continuous based on the flow of magma. I hope this was helpful. See you guys next time.